Hey guys, so this is review for the upcoming test this Tuesday on all things functions. I went through as I usually do and looked at the test itself, made a list of the concepts, and so as we go through, I'm going to make sure that we have covered them all. But the test is on functions, and basically everything that I ended up writing down included the word functions. Whether we're talking about domain and range of functions, whether we're talking about composition of functions, inverse functions, things of that nature, certainly that was all there. So I'm going to pause for a sec while we pull up the handbook. Okay, so here we go. Let's see what we've got. All right, so first off, we talk about what a function is. In fact, first we talk about what a relation is. A function is a kind of relation which, if you tell me what the input is, I have to be able to tell you exactly what the output is. Not the case with a relation, like the graph of a circle is a relation or something like that. If I say a first name and you say all the last names which could go with it, that is a relation, because if I say Dan, there might be plenty of them. When I went to Harvard Westlake, I was one of 6 or 7 Dans in my class, depending on what year, 7th through 12th grade. So certainly that wasn't a function. You said, oh yeah, the kid whose name was Dan, you could be talking about Dan Reeves, Danny Abdomalik, Danny Mason, any of those. And give a shout out to some of my old friends there. So that would be a relation. A function, on the other hand, would be if, say, you give me a phone number, I could tell you, I mean, I physically couldn't, but one could tell you the address associated with it, where the bill for that particular phone number goes. There won't be, for any phone number, it won't go to several different places. That bill goes to one place. So this is just good ways of having us visualize it. I think we pretty quickly moved beyond that. There can be some confusion when we say y is a function of x. When we say is something a function, that's really what we're asking. You tell me what x is, and I can tell you with certainty what y is. Of course, it could go the other way around. X is a function of y. If you tell me what y is, I can tell you with certainty what x is. But generally speaking, if we just are asking, is something a function, we're not really asking the second one. We're really just asking this first one. You're saying, if I tell you what x is, can you tell me with certainty what y is? So over here in number 2, if I were to graph it, it would be a circle. That means that for one value of x, there are multiple values of y. If I tell you that x is 3, for example, you can solve this and find that y is plus or minus 4. That or in there means out. Nope, can't do it. Here's how functions are normally written. Y equals something, where it's literally just instructions of what you do to x. And since you just do these one set of instructions, whatever x is, you will get a specific y every time you do. Same over here where we get x squared is equal to y. You tell me what x is, tell me that x is 3, I'll get 9 every single time. Visually, this one, kind of wacky, not a function in the normal way, in that if you tell me that x is, let's say, 1, then y looks like it could be like a negative 1.2 or a positive 3.2 or maybe even a negative 4. A function is one-to-one if y is a function of x and x is a function of y. A function is one-to-one if, in addition to passing the vertical line test, as every function should, it also passes the horizontal line test. The vertical line test, every function needs to be able to pass that, because that is, if there is a vertical line that it will only intersect at most 1 point. If it didn't, then I would be saying, oh, there's 2 different y values associated with this one x value. Hopefully we recognize that this is the equation for a line. So that is a yes on both A and B, and it's a line. This one you don't necessarily have to recognize yet, but it is a hyperbola. It is hyperbolic. Still, yes, you tell me what x or y is. I can tell you what the other one is. Looks like a hyperbola. I don't really care. The third one is a circle, so that one's a no. Let's continue on. Okay, domain and range of functions, definitely something from my list. In fact, something which got some check marks. So there are 2 things which restrict the domain, and that is that I'm not allowed to divide by 0. So in the second one, f of x may not equal 3. Or I'm not allowed to take the square root of a negative number. 0 is fine. So anything from -7 and above would work here. So the domain would be a square bracket, -7, comma, infinity, and always a circular bracket with infinity. This domain, I would just say x is not equal to 3. Of course, we can do it in interval notation as well. The range is a little bit trickier. So in general, we can just observe what the range should be. This is a line with a slope of 5. So it goes positively up and negatively down. It's going to hit every y value. Here, hard to see sometimes, but it is a fraction. And the only way to make a fraction 0 is if the numerator is 0. And since 2 is never equal to 0, this one, the range is y may not equal 0. We will come back to situations like this a little bit later on and see a different way of solving that, which is a little bit more sophisticated. The square root of anything is always positive or 0. So the range here is everything from 0 to infinity. Composition of functions, also something which got high billing on my list of things. I hear a small child. I'm going to pause for a second. You got what now, honey? All right, there's a small child present, but hopefully this will work out nonetheless. Composition of functions is when you take the output of one function and plug it directly into another function. So this doesn't spell fog of x, it says f composed with g of x. You do the one which is closer to x first. I happen to like this notation better because it's really more telling. You do g of x, and then whatever comes out of that, you plug into f of x. So your g function might be g of x equals 2x, double it. And your f function might be add 7. So together, they're double it and then add 7. Over here, some examples. We know what f of 5 is. It's 5 plus 4. We know what g of 4 is. It's the square root of 4. It's 2. So we got 9, we got 2. Over here, we're doing some composition stuff, though. So first, I do g of 4, which we said was 2. Then I have to do f of 2, which is 6. Same idea over here. F of 5, we already said was 9. Then I get to do g of 9, and I get 3. These examples, we did f composed with h of 7, h composed with f of 5, et cetera, et cetera, et cetera. And we kept on getting whatever it was that we started with. So this was inverse functions, another of our concepts which is high on the list of important concepts for the chapter. In order to prove that functions are inverses of one another, you have to prove that f composed with h of x and h composed with f of x are both equal to x. So it's not that it happens to work for some value. or for some other value, or even for a whole lot of values, but it must work for all x's. So inverse is just the mathematical way of saying we undo one another. You've been dealing with inverses in math from the very beginning. You learned how to count forward, and then you learned how to count backwards. Counting forward is essentially just adding one at a time, but you learned how to add other things and then subtract. Those two things are inverse operations. Multiple of addition is multiplication, and its inverse is division. And on and on and on. Okay, back to some domain and range. Really quickly, that's a line. The domain and range are all real numbers. The domain here, x has to be greater than or equal to 0, but the range is greater than or equal to 1. Here, the domain x can't equal 2. The range y may not equal 1. And so far, we're still at that. Hopefully you see it. In order for a fraction to equal 1, the numerator has to be equal to the denominator. If you don't see that yet, don't worry. We do have a sneaky method for finding the range of things. Oh, small child. Let me pause this. I really need to come up with some bingo cards for things which interrupt me in the middle of my lessons. I can yell, bingo! Yes! My cat jumped on my baby and whatever. Okay, so domain and range, and we are getting ever closer to finding another way of finding range. Another way of looking at compositions of functions, even if we don't have a numerical description of what the function is, a graphical one could do. We can figure out what f of 3 is. Whatever it happens to be, plug it in for f. We can find out what that is. Whatever that is, plug it in for f again. So for example, f of 3 appears to be -2, f of -2 appears to be 0, and f of 0 appears to be 4. So there's my answer to that jumble. Domain and range are sometimes not just defined mathematically per se, but sometimes by the situation. Like here, x minus 3, if someone just said, hey, what's the domain of x minus 3? I'd say all real numbers. But if x minus 3 is representing the side of a rectangle, well, all of a sudden, x has to be greater than 3. Okay. Always fun here. Build your own composition of functions. There are innumerable correct answers for things like this. Go with something simple is my advice. So my first function, I'm going to make x minus 4. And my second function, I'm going to make the square root of that. So I take the square root of this, x minus 4. We hear a loud baby coming. Let's see if we can get through some more stuff. Blank page, inverse functions. Okay, inverse functions, what does this mean? An inverse function graphically will contain kind of flipped points. So if the point a comma b lies on f of x, b comma a lies on its inverse. We saw that on the practice quiz. We saw that on the homework. So definitely a thing. So whatever function you draw here, if it goes through the point 1 comma 0, which I guess is over here, then its inverse should go through 0 comma 1. And remember, things are inverses of one another. They undo one another. Think of a function which contains the point a comma b as a function which takes an a and makes it into a b. The inverse to that would be taking a b and making it into an a. Where these graphs intersect would always be a point like 7 comma 7, 15 comma 15, and negative 12 comma negative 12. To find an inverse. Okay, so find the inverse of 4x plus 12. I'm going to write it down. F of x equals 4x plus 12. there's a logical way of doing this as well. Thinking, okay, well, what's happening? First, it's getting multiplied by 4, then it's being added to 12. We can undo that in reverse order and subtract 12 and divide by 4, and that will work. But for more complicated cases, this is what I do. You take f of x and make it into x equals, for all the x's, you turn into y's, and just solve for y. So I'm going to subtract 12 from both sides and divide both sides by 4, x minus 12 over 4, and simply change that in the end to be f inverse of x equals x minus 12 over 4. We can prove it if we show that f composed with f inverse of x equals x, and f inverse composed with f of x equals x. Doesn't ask us to. Let's just see whether or not it seems legit by picking a nice easy number. How about 0? Plugging it in. 4 times 0 is 0, plus 12 is 12. 12 minus 12, I'm taking the output, which was 12. 12 minus 12 is 0. 0 divided by 4 gets me back to where I started. That wasn't a proof or anything, but it does lend credence to that being an inverse. Okay, INV. INV is a relation, which may or may not be a function, which is the inverse of a function. A function will have an inverse function if that function itself was one-to-one, if it passed both the vertical line test, so it had to be a function to begin with, and the horizontal line test. So y equals x squared does not have a inverse function. It does have an INV. It does have a inverse relation. 2x plus 4 is one-to-one. It will have an inverse function. This one will not. This one will. This one is a headache. Don't try it. Okay, graph each function and its inverse. Once again, number 2 is a headache. Don't try it without a graphing calculator. Although maybe it's not as bad as I think. Back to our next squared. I don't know. Over here, still is kind of on the ugly side. Yeah, let's not pause here. Not particularly useful. Okay, so frequently we'll take things which are not one-to-one and we'll just limit their domain so that they are. If we only look at x values, which are greater than or equal to 0, this is only one branch of a parabola. It is going to look something like this: 1, 2, over 1 up 1, over 1 up 3, kind of something like that. And it's one-to-one. It clearly passes the vertical line test. I can't draw a vertical line which hits more than 1 point. And it passes the horizontal line test. I can't draw a horizontal line which hits more than 1 point. So now I can come up with an inverse function for this. To graph it is not hard. If it goes through the point 0, -2, then the inverse should go through -2, 0, and kind of do the same thing. By the way, does that look like it's on the line y equals x? I certainly hope so. And we can follow our normal rules for finding the inverse mathematically as well. This gets us to the point that the domain of a function is the range of its inverse, and the range of a function is the domain of the inverse. Those two things are intrinsically related. Now, we kind of skirted the issue of finding some tricky ranges early on. Now we're ready to dive back into that and say, oh, okay, well, domains are always easy to find. So if I can find the inverse and I can find the inverse's domain, then I have found the function's range. So that's kind of neat, kind of fun. So sometimes we are asked to find a restricted domain. If it's a parabola, really look where the vertex is and take it and every point to the left, or usually it and every point to the right. There are other ways of doing it, but that is really the go-to easiest thing. This is in vertex form. It has a vertex at 1, 3. So I would restrict the domain so that x is greater than or equal to 1. This is like a problem. The fact that it has a vertex comes to a single point. That point is the point -4, 0. So I would again restrict the domain so that x is greater than or equal to -4. Okay. I think we're kind of coming to the end of the concepts that that I've got in here. Restricted domain, the last one that we covered here, and seems like we're pretty much there-ish. Okay, so a little while ago we had a function f of x equals x over x minus 2. And we were able to look at it and determine, oh yeah, it stands to reason that the range would not include 1, because x may never equal x minus 2. But again, there's a chance that you don't see that. So what I'm going to do is I'm going to find the inverse function here by saying that this is x equals y over y minus 2. Let's multiply both sides by y minus 2. I'll get x, y minus 2x equals y. My goal is to solve for y, so I'm going to move all the y's to one side. X, y minus y, and move everything without a y to the other side, equals a positive 2x. Factoring out the y is my pro move. X minus 1 equals 2x. And y equals 2x over x minus 1 is that inverse function. So I'm just going to say equals f inverse of x. The domain of this is clearly x may not equal 1. So the range of this, oh yeah, stands to reason y may not equal 1. I think that's going to cut it for us. Is there anything else that I needed to cover? I'm just looking at this thing. I feel like we glazed over operations on functions. So things like 3f of x. If f of x is equal to 2x plus 7, then 3f of x is equal to 3 times 2x plus 7, that are known as 6x plus 21. You can add two functions together. You can subtract functions from one another. You can divide them. You've seen this for sure in your practice homework, practice quizzes. We've graphed those. Not a major concept and not usually something which tends to be altogether that confusing. So I think we can leave it there. All right, guys, if you do have questions, feel free to email me. Other than that, I will see you on Tuesday for our test. Looking at what kind of day today is. It is a day 4. Yes, we X on Monday, test on Tuesday. So if you do have questions, Monday is a good day for asking them. All right, have a great weekend, everyone. It's my birthday weekend, so I'm planning on having a fun one. Do me a favor and have a fun one as well. All right, bye, guys.